everybody, in this video we're going to be talking about the greatest common factor, and I'll give you 4 different methods that you can use to find the greatest common factor. So the greatest common factor of two whole numbers is the largest whole number that is a factor of both numbers. So remember, a factor is basically a number that the number can be divided by evenly. Or in other words, it's like one of the things that can be multiplied together to get the number you're looking at. So when we're finding the greatest common factor, we're always going to find it between two whole numbers, or you can also find the greatest common factor between 3 or 4 or 5 numbers. But basically, we're just looking for a number that is a factor of both numbers, and we want to find the largest possible one. So for example, the greatest common factor of the numbers 24 and 36 would be 12, because that's the biggest number that both of the numbers 24 and 36 can be divided by. And there's several different methods that we can use to find the greatest common factor. The first one is called the set intersection method. So the way that the set intersection method works is you're going to list a set that includes all of the factors of each number. So I'm going to start off by making my set for the number 24, and I'm going to think of all of the numbers that multiply together to equal 24. So one of the factor pairs would be a 1 and a 24, and I'm going to separate them so I can write them out in order. But 1 times 24 equals 24, so those two are factors of 24. I would also have 12 and 2, because 2 times 12 equals 24. If I divide 24 by 3, I get the factor 8. And 24 is also divisible by 4, and 4 times 6 equals 24. And so this list of numbers here is a list of all of the factors of the number 24. And notice that with the way that I did it, I didn't have to check numbers like, oh, is 24 divisible by 11 or 13 or things like that, because I just started with the smallest possible factor and found the number that you multiply it by to get 24. Then I did my next smallest factor and found its pair, and the next smallest, and so on until you get to like the middle. And the only number that I would still need to check is the number 5, because that's in the middle of 4 and 6, but 24 isn't divisible by 5, and so that doesn't end up being relevant. And so this is a list of all of the factors of the number 24. Then I can also make a list of all of the factors of 36. So if I think about the things that multiply to be 36, I would have 1 and 36. I would have 2 and 18, and 3 times 12, and let's see, is it divisible by 4? Yes, so we'd have 4 and 9, and it's not divisible by 5. It is divisible by 6 though, so I will add 6 to my list of factors. So this blue set is the set of all of the factors of 24. The red set is the set of all the factors of 36. And if I look at the intersection of these two sets, so let's say I call this set A and I call this set B, remember the intersection is basically the overlap between the two sets. So the overlap between these two sets would be 1, 2, 3, 4, 6, and 12, because those are the numbers that are in both set A and set B. And so with the set intersection method, the way that you find the greatest common factor is you basically just look for the largest number in the intersection of the two sets, because these are all of the common factors between 24 and 36, and we're looking for the greatest common factor. So that's the way that the set intersection method works. The next method I'm going to show you is the prime factorization method. So I'm going to find the greatest common factor of these same two numbers again, but I'm going to show you a different way of thinking about it. So if I find the prime factorization of the number 24, I might say, okay, well, 24 is 4 times 6. So I might split it up into those two factors. Neither one of those is prime, so I'll break them down further. And 4 is 2 times 2, and both of those are prime. 6 is 2 times 3, and both of those are prime. And so 24 equals 2 times 2 times 2 times 3. Then I can go ahead and find the prime factorization of 36, and I can say, well, 36 is 6 times 6. Neither one of those is prime, so if I break 6 down further, I get 2 times 3, and both of those are prime. This 6 can also be broken down into 2 times 3. So the prime factorization of 36 is 2 times 2 times 3 times 3. And then once you have the prime factorization of each of the numbers that you're trying to find the greatest common factor of, then you just say, okay, well, the greatest common factor of these two numbers is going to be the prime factors that they share multiplied together. So both of these numbers have a 2 in common, so my greatest common factor is going to have a 2 in it. And they actually have 2 2's, so I'm going to have 2 2's in my greatest common factor. And then this one also has a 3, and so does this one. So I'll multiply by 3. And those are all of the prime factors that they have in common. And so then I'll just multiply these together, and 2 times 2 is 4, times 3 is going to give us 12, which is the same answer that we got with the set intersection method. So that's the way that the prime factorization method works. And then the next two methods I'm going to show you are really useful for when you're trying to find the greatest common factor of big numbers, because it's relatively easy to find the prime factorization of a number that's less than 100. But when you get up into really big numbers, the prime factorization process can take a long time. And also the set intersection method takes forever because there may be like tons and tons and tons of possible factors that you would want to list in your set. So the way that the calculator method works is based on a theorem in your book which says that the greatest common factor of any two whole numbers, so let's call them A and B, equals the greatest common factor of the bigger number minus the smaller number and the smaller number. So in this case, I'm assuming A is greater than or equal to B. And I can use this theorem to help me find the greatest common factor of really big numbers. So if you want to understand why that theorem works, you can read in your textbook and see the explanation for why this theorem is true. But I'm just going to go ahead and use this theorem to help us find the greatest common factor of 546 and 390. So if I were to use this theorem, I would say, well, this greatest common factor is the same number as the greatest common factor of 546 minus 390, which is 156. And the smaller number, which is 390. Then I could apply this again, and I could say this greatest common factor is equal to the greatest common factor of the bigger number, which is 390, minus 156, which is 234, and the smaller number, which is 156. Then I could say, okay, then my next step would be that this is the greatest common factor of 234 minus 156, which would be 78. So I have 78 and 156 because that's the smaller number. So by the way, it doesn't matter which order these are placed in. It's just which one's bigger and which one's smaller. Because with the greatest common factor, it doesn't matter which order you write the numbers in. So then the next step is to find the greatest common factor of the difference of 156 and 78. And when I subtract 156 and 78, I get 78. And the smallest number in the pair is also 78. And so that means that I am trying to find the greatest common factor of 78 and 78. And that's just going to equal 78 because since it's the same number, they can both be divided by themselves. And so that's the largest factor that they have in common. And so that's how you would use the calculator method to find the greatest common factor of these two numbers. And then the last method that I'm going to show you is called the Euclidean method. So the way that the Euclidean method works is you take the larger number, which in this case would be 3,432, and you divide it by 840. So when I do that in my calculator, I get the number 4.0857, blah, blah, blah. But I'm only looking for how many times does 840 go into 3,432. And since when I divided it, I got 4 this big long decimal, that means that 840 goes into this number 4 times. And if I multiply 840 times 4, that tells me that I put 3,360 of my numbers and I divided those up equally. And the amount that I have remaining is 2 ones and let's see, that would be 7 tens. So my answer to 3,432 divided by 840 is 4, remainder 72. Then what you do next is you take this number, so 840, and we're going to divide that by 72 because that was the remainder. So when I do 840 divided by 72, that gives me 11 this big long decimal, but mostly I'm just looking for the whole number. So I say, okay, it goes in 11 times, and 72 times 11 is 792. If I subtract that, I get 8 ones, and let's see, that's going to be 13 minus 9, which is 4. So I get remainder 48. And then I do the process again, and I say, okay, well, 72 divided by the remainder, which was 48. If I divide that out, 72 divided by 48 is 1. And 1 times 48 is 48. I subtract that, and 72 minus 48 equals 24. And then I repeat the process again, and I do 48 divided by 24. And when I do 48 divided by 24, that gives me the number 2. And it's exactly 2 with no decimals. And we can test that because 2 times 24 is 48. And when I subtract that, I have no remainder. And so this tells us that the Euclidean method is done. And the greatest common factor of these two numbers will be the number that you divided by that did not create any remainder. And so the greatest common factor of these two numbers would be the number 24. So those are 4 different methods you can use to find the greatest common factor. And these processes, or the process of finding the greatest common factor, can be useful in several situations. But one of the ones that we use the most often is when we're reducing fractions, because when you have 2 numbers on the top and bottom of a fraction, if you can divide the top and bottom by the greatest common factor of those 2 numbers, then you'll only have one step of dividing instead of having to reduce in multiple steps. So that's how you find the greatest common factor. If you have any questions, let me know.